Remainder theorem states that if a polynomial p of x is divided by x minus c, then the remainder is p. So when number 1 asks us to find p of negative 2, not only we can find this by just substituting x equals negative 2, we should be able to use division to find the function value. So let's try to find p of negative 2 just by what we already know how to. Let's go ahead and just plug in negative 2 into this function and find the function value. 3 times, and I'm using this function right here, 3 times negative 2 to the 4th power minus 2 times negative 2 squared plus 12 times negative 2 minus 1. Now I will go to my calculator, and I did type it in already, and as you can see, that comes out to be 15. So we know how to find p of negative 2. So this time, let's use the remainder theorem. Remainder theorem says if p of x is divided by, they said x minus c. So we're writing the factor given the zero form. So if c is negative 2, do you agree with me that we're dividing this by x plus 2? Then, if you do this division, the remainder is p of negative 2. So basically, they're telling us to divide and look at the remainder. So here's the division problem that I will do. I will go ahead and divide this p of x, 3x to the 4th power minus 2x squared plus 12x minus 1. I will divide this by x plus 2. And you have two options. You can do this using long division or synthetic division. Up to you. In this video, I will show you how I do this division using synthetic division. So I put little 2. I put the 2 into my box, and let me write down the coefficients. But when I'm writing down the coefficient, I have to be very careful to put zeros whenever they skip a term. You see they started with the 4th degree, so I put the 3, but they're missing the 3rd degree. Cubic term is missing, so that's why I put 0 after 3 and before negative 2. And then the next is just x to the 1st power, so that's okay. I'll go ahead and write positive 12, and lastly the constant of negative 1. Let me start my synthetic division. I bring down the 3 without doing anything. And then we multiply negative 2 times 3. We put that negative 6 down 0, and we will add vertically. 0 plus negative 6 is negative 6. We multiply again. Negative 2 times negative 6 is positive 12. I put the 12 down here. And then it's time for us to add again. If I add negative 2 plus 12, I will get 10. Time for us to multiply again. Negative 2 times 10 is negative 20. And let's add. Adding these two will give us negative 8. Last multiplication. Negative 2 times negative 8 is positive 16. And finally, if I add these two numbers, I will get 15. Didn't we see that 15 before? We got the remainder. Remainder is 15, which means p of negative 2 is 15 by the remainder theorem. So you saw two different ways. we did the first method, the way that we used to do, just substituting -2 directly into the function. The second method, we did try to use the remainder theorem, and as you can see, both times we ended up with an answer of 15. Let's look at the one in the back. It's a slightly different problem. They are telling us to find the remainder. So our initial thought to me is, well, I better divide. But looking at how special this little problem is, you see how we are starting with 2x to the 89th power. So do not do this. I'm about to set up my synthetic division. I see what we are dividing by. I will put -1 in my little box, and I will try to set up my synthetic division. I'll write down 2. But notice after 89, I am missing 88, 87, 86, all the way down to 65, and then the next one is 64. So not only that I have to put so many of these 0, ... setting up a synthetic division or long division for an 89th degree polynomial will require us to write 90 different numbers or 90 different terms when we set up those divisions. It's not gonna work. It's too much. It's funny because one semester, guys, I gave something like this and one student actually did division problem. And I had to give him the credit. He did a good job. But I created this problem because I wanted you to do or use the remainder theorem, okay? Now, notice how I'm asking you to find the remainder. Oopsies, my pen died. I'm going to go ahead and just plug it in real quick. Notice I'm asking you to find the remainder. Let me go up and look at the remainder theorem with you for one more time. Remainder is P of C. You see the very last part of the remainder theorem, they say remainder is P of C. So without really finding the remainder, if we can just evaluate the function value, then we should be able to find the number that is same as the remainder, right? So instead of actually finding the remainder, we're going to go ahead and use the direct substitution. We're going to just plug in the number, and that number is going to be the remainder of the division. And we can probably use Mathway to check, because that's a computer. They can do a division with 90 terms. And that's something that, we won't do it ourselves. But let's go ahead and first use the remainder theorem to find the remainder. Okay, so let's find they never really call this a polynomial, but can I just call this P of x? Okay, I'll just call that P of x. And I am dividing by x plus 1. So I will go ahead and find C equals -1. I will go ahead and substitute or find C equals -1. Okay, so let's find P of -1. And I got worried a little bit because if you raise something to 89th power, you're multiplying that number by itself 89 times. And unless it's a special case, it's going to make the number very big. But -1 or +1, if you multiply it by itself, it's not really going to get bigger. So let's go ahead and find it. P of -1 is 2 times -1 to the 89th power minus 6 times -1 to the 64th power plus 5 times, and you have to be very careful with signs here, okay? 41 plus 2 times -1 to the 20th, and then finally minus 3. I'm going to go ahead and use my highlighter to circle what we are now going to look at. You see, we're going to evaluate or simplify these powers first, okay? So these. Whenever you have even degree, it's going to turn into positive. But notice 89 is an odd number, so this will stay as -1. Okay, next, I'll copy down my -6, but notice 64 is an even number, so -1 will turn into +1. Let's keep going. Bring down the +5. Look at the exponent of 41. 41 is an odd number, so this one stays as -1. Almost done. We do +2. And we're multiplying this by 20 is an even number, so -1 will turn into +1. And I'm going to bring down the -3. I did all this work without a calculator, so I'm determined to finish without a calculator. -2, -6, -5, +2, and -3. We just have to add these numbers together. Let me try. I can see this -2 and +2 will cancel out, leaving us with -11 -3. So my final answer is -14. So this is P of -1. So this is the remainder. This is going to be the same as the remainder to this division problem. So we did this using the remainder theorem. I'm going to go find an online calculator who is willing to do a division of 90 different terms, okay? So how about I go to our favorite little Mathway just because I want them to do this. I don't really use this to do homework problem. You really should not, okay? You should be trying to do this yourself, but I just want to see if a computer can just find the remainder for me, because what I want to know is my answer correct? And I don't mind if you use these calculators to check your answers on your homework, as long as you really know how to do the problems yourself, right? That makes sense. How do I type in the division symbol? Oh, they have that right here. And then I'm dividing by x plus 1. And because when I'm grading your exam, I will ask you to show me all this work that we wrote down. Let me go ahead and click on it and say, using synthetic division. Okay, I'll click on that and I'm going to show you what they will do for us. Oh my goodness, do you see that? Do you see all this? Oh, they got so many ads. We're trying to do some math over here and oh my goodness, look at all that work. But where is the remainder, the answer that we're looking for? Do you see they wrote it as -14 over x plus 1? So we skipped finding this quotient and we went straight to the remainder because that's what they were asking. And -14 is the answer that we got. How about I just click on this and ask them to find the remainder only this time? Find the remainder. I am unable to solve this problem. Silly, you will solve this problem. Find the remainder. They're not going to solve it. They probably want my money to solve it. But how about I tell them to do a long division? They will do it. You see, what do you mean you're unable to solve this problem? How about do synthetic division again? I don't know why, but they will do synthetic division, but wouldn't do the long division, wouldn't just spit out the, what's it called? The remainder for me, but we know where to look. We see that the remainder is -14, and if you notice, that is the answer that we got from using the direct substitution method, right? I call it direct substitution, but simply just finding P of -1 got us that answer. So I will put one like this on your exam, and I expect you to use the remainder theorem instead of just giving me the remainder from some magical Mathway source. Okay, so that's it for this video. Come back and watch the factor theorem video for me, okay?